Well, hello. So yesterday I was working with a student. I was tutoring her in statistics, and we were going through how you could use Excel to solve normal distribution problems that the teacher had assigned. And we were using the norm dist and the norm inv functions in Excel, and then hand sketching the normal distributions. But then I remembered after the session of tutoring, I remembered that her teacher had also allowed for using the Staplet.com tools. So I took a look at those tools, and lo and behold, there's a lovely tool there that does the same thing. So I thought I'd put together a video on how to use the Staplet normal distribution tool to solve problems. So to do that, we're going to need a problem. And I went on to, so OpenStax offers a bunch of free textbooks. In this case, these three authors created a textbook called Introductory Business Statistics. It seems like a nice textbook, and I was able to find an interesting problem in Chapter 6, Section 2. And that problem, that's just so that we have something that we're trying to solve, is we've got a farmer who has been measuring oranges that they have coming off their farm. Hopefully they did a sample. They didn't measure all of them, but when they looked at the data, they found that it followed a normal distribution, and that the mean diameter for the oranges was 5.85 centimeters, and there was a standard deviation of 0.24 centimeters. Now, it's good that the data followed a normal distribution because, well, we wouldn't be able to use the normal distribution tool to solve if it didn't. But thankfully, we're told it follows a normal distribution, and so we can use the tool. Let's see. So let's look at the first question. The first question is, find the probability that a randomly selected orange from this farm has a diameter greater than 6 centimeters. And then sketch the graph. Okay, well, all right, so you go to this farm, you randomly pick an orange off of a tree. What's the probability? What's the percentage chance that you would get an orange that has a diameter greater than 6 centimeters? And that's exactly what we are going to calculate. So we'll move over to the Staplets.com website. You can see I still should be exploring more of these, but we're just going to be using the normal distribution tool under probability. And if you've never used it before, it'll show up like this. First of all, it says, well, what do you want to do? And you have two options. You can calculate the area under a normal curve, right? Or you can calculate the value corresponding to a specific area. And that's the inverse, right? If we think of these as the Excel commands, dist norm, dist, dist is going to be calculating the area under the curve. Norm inv is given a value, given a area, a percentile, what's the value corresponding? So if we look back at these problems, the first two, we're going to use area under a curve. So that's just the first one. We do need the mean value, and we need this standard deviation. Let me verify that. 5.85 and 0.24. You absolutely have to make sure that these numbers are exactly what you were given, because if they're not, you'll get answers, they just won't be the right ones, right? So all the answers we're going to be getting are going to be using this mean and this standard deviation. We plot the distribution, all right? Here we go. There's a lovely normal curve all drawn out for us already. The mean, you can see, is right here in the middle, and that goes up to exactly where you expect it, the top of the normal distribution. Let's see, so 6.09, where did they get that from? Well, if I add 0.24 to 5.85, I get 6.09. So this is one standard deviation above the mean. And this indeed is 2 standard deviations above the mean, 3 standard deviations above the mean. And then we go the other way, 1 standard deviation below the mean, 2 standard deviations below the mean, 3 standard deviations below the mean. There we go. And this curve is always going to look exactly the same. The only thing that's going to change are these values that are graphed on the bottom, labeled on the bottom. Okay, so we've got that. Obviously, though, we don't have an area yet. Well, because we have a question. Calculate the area. We have 4 choices. Between 2 values, to the left of a value, to the right of a value, and outside of a region. Now, each of these, there's 2 pairs here that are complementary. Between 2 values and outside of a region are complementary. So outside of a region, you give it 2 values, and then it'll give you basically the area of the tails, but not the center. Between 2 values is going to give you the area between the 2 values in the center of the distribution. To the left of the value will be from -infinity up to the value. To the right of the value is going to be from the value to positive infinity. Okay. And again, just like the mean and the standard deviation, we have to put in the right question to match the one that we were given. Let's look at the question again. Diameter larger than 6 centimeters. Larger. So we're expecting 6 centimeters and greater. If I look at the curve, 6 centimeters is going to be about here, and then greater is going to be to the right. So we want to switch this to the right of the value. And I type in the value, 6.00, and I just hit calculate area. There we go. So, and we can see on the picture, I can see where the 6.0 shows up on the x-axis, and I can see this is all shaded in to positive infinity. And it nicely calculated the area for us. It even gives us the z value for 6 for this data, but we don't have to go to z-tables and do any of those sorts of calculations. It's done it for us. We can show labels on the graph, and that gives us a little bit more information. But there we go, we're done. So 26.6%, round that to the nearest integer. We get an answer of 27%. And then we could use that graph from Staplet to graph the answer. And then we're done. All right, okay, well, now that we've done that, we can try another problem. All right, here is, okay, you're randomly picking an orange again. But now you want to know what's the chances that you're going to get a orange that's between 5.4 and 6 centimeters in diameter. All right, so we got now 2 values, and it does say between, right? So we're going to switch this to between 2 values. All right, and I just want to say Staplet is nice. They will keep the information, so they'll keep the mean and the standard deviation for you, so you only have to change these values. But do be careful. If you start another problem, don't go immediately here. You're going to need to go back and make sure the mean and the standard deviation match your new problem. All right, so here we want to calculate the area between 2 values. The left value is 5.4. The right one is 6, right? So the smaller one is on the left. The larger one is on the right. I could go back and check the problem, but let's see, 5.4 and 6. Yes, calculate the area. And there we go. It gives us the z-values, but we don't even need them. All we have to do is just look at the answers. 70.36%. Round that to the nearest integer, we get 70%. So there's a 70% chance that if you pick an orange on this farm, you will have a diameter between 5.4 and 6. Right? What's the probability? What's the probability of not picking something between those? Well, we could switch that to outside the region. And you can see, right, this is what I was saying earlier. They're complementary, right? This area is 3, this area is 27. Add those together, you get 30, right? And 100% right? The whole curve is 100%. 100 minus 70 is 30, right? So you really only have to do one of them, and you can calculate the other one based off of you knowing that the full curve is always going to be 100%. All right, so go back to the problem. Our answer is 70%, right, between those values, and we've got a lovely curve. Okay, now for the last problem. Now here's where we are doing the inverse, right? We're given a percentile, 20% of 20% area. Right? What diameter matches that? So coming back here, we're going to have to switch the operation to calculate a value corresponding to an area. It's keeping the same mean and standard deviation, and for this problem, those are the right values. And then we're left with 2 questions left that we have to figure out. Calculate the boundary value for the left tail, right tail, or central. Central is going to give you the area centered around a value, percent value. Left is going to use the area to the left of. It's going to find the area to the left. Right tail is going to use the area to the right. Right, and then we're going to have to put in the area. Right. So in this case, we're 20 percentile. So basically up to 20. So that's going to be to the left. And we do have to do a little work here. 20% areas add up to 1. 20% is going to be 0.2, right? So there's this conversion of percentage to decimal, right? Divide by 100. And if we calculate the value, we find that 20% of the apples will have a diameter less than 5.65, if I round that to 2 decimal places. Right? So I would say, so yeah, there we go. When we come back here, 5.65 centimeters, and there's the graph. Okay. Well, I hope you found this useful. I had fun making it. Thank you.